Howdy, everybody. Hey.
Hi.
Hello. So today what I want to do is talk about some work that we've been doing looking at calculating application attack surface and some additional things that we've been doing looking at how you can use these calculations as you look to start to include security testing in your DevOps pipelines. Just agenda, provide a little bit of background, talk about the importance of attack surface. Why is this something that is interesting? We'll look at what attack surface calculations, how we've used that to benefit with DevOps, and really that's looking at it's come out of some realities that you have to face when you start to look at integrating security tools into DevOps pipelines. We'll talk about the underlying technology, hybrid analysis mapping technology that we've developed, funded by the U.S. Department of Homeland Security. Talk about a couple of use cases, some things that we're doing with this right now, and some things that we're looking at doing. And we'll have some time for questions at the end. If you have questions along the way, please feel free to, you may need to wave your hand a little bit because I've got some lights shining at me, but happy to answer any questions along the way. My background, just to set some context, again, founder, CTO, Denver, I'm a software developer by background with a lot of Java stuff in the mid to late 90s, .NET stuff in the early 2000s, but really what I've spent the majority of the last 15 years doing is working with organizations to help show them how the code that they are developing and the code that they are deploying impacts the security of those organizations. So I'm a developer that has come into the world of security as opposed to being someone with a pen testing or like a network pen testing background that has come and is now looking at web and mobile apps. And so that kind of colors the view I have on these things. And I help, along with some other folks, run the OWASP San Antonio chapter and have been doing some work with OpenSAM benchmarking. Is everybody here familiar with OWASP Zap? Anybody not familiar with Zap? If you're not yet familiar with Zap, you should download the slides and click on this link. Some of the examples we'll use OWASP Zap. Zap is a freely available dynamic scanning tool and maintained by Simon Bennett and a worldwide group of volunteers. It's a fantastic open source project, really great community, and a great tool that you can see kind of the things we're talking about as well as other examples of people starting to use OWASP Zap as part of their CI/CD pipeline. We've also got some example code bases that you can try the stuff that we are going to be talking about here. So those links are available as well. And like all of the code that runs this is available. You can pull down from the community edition of ThreadFix up on GitHub. And we've also got some downloads here if you want to just get prepackaged stuff and not have to build things. So that's really kind of housekeeping for once if you download the slides and you have questions or want to try this stuff out. So there you go. Attack surface is kind of the fundamental or the building block thing that we're talking about here. And that's something that I think is really important for security in general. You need to know what you're trying to defend. If you don't know the extent of the things you're trying to defend, you're probably not going to be terribly successful in defending them, just in general. And that's a big problem in even small organizations, certainly organizations, large enterprises. If you just think, not even thinking from an application standpoint, just their exposure that they have, different networks, different data centers, various cloud services and things like that. In a non-trivial organization, it can be really challenging to have an understanding of attack surface. And again, if you don't know what your attack surface is, you're going to have a lot of trouble defending it. When I talk about attack surface in the context of applications, specifically web applications, what I'm talking about is where can an attacker reach out and touch your application? And from a practical standpoint, this really means what are the set of HTTP requests that can be made against your application where your application is going to do some processing based on that. So what are the URLs that folks are going to be able to access? And for each URL, what are the parameters that you can pass in that will change the behavior of the application or other parts of the attack surface? If you think of HTTP headers and cookies. And so really what we're asking is, what are all the different points on your application where an attacker has the ability to send in an input that is going to have some sort of impact on the behavior of the application? And so looking at this is really looking at how what you would target when you're doing dynamic testing. Whether that be automated DAST, that's a nice Gartner term, dynamic application security testing, or looking at manual assessment or manual penetration testing of applications. So what does attack surface have to do with DevOps? Well, first of all, if you want your talk to be accepted these days, it has to be about DevOps. No, wait. The way we've actually started looking at this is to figure out what do we want from security in the DevOps pipeline. And to figure out, especially when you look at the constraints that you have in an organization, if you look at the time and resources it takes to do security testing, to run security testing tools, to do manual testing, what we've done is taken a really hard look at attack surface and the evolution of attack surface, and we're using that to focus in efforts because we typically have limited resources and you need to focus those resources in where they're going to be the most valuable. And we'll talk obviously more about that. Organizations like Etsy and Netflix are doing amazing things in their DevOps pipelines for, from a security standpoint to say, if I were to deploy this build, what's the security state going to be of that deployment? Have I broken any of the assumptions that I had leading up to this? Again, those organizations are doing really, really cool stuff. When I think from an application standpoint, when I look at security in the DevOps pipeline, there's really 3 steps that happen, or 3 phases that you go through during your CI/CD or during your build. The first is the testing phase. You want to do some sort of testing of the application against your set of assumptions to ask, does this application have vulnerabilities in it? Can I discover vulnerabilities in this application? And what we've worked with organizations doing is to determine, some of that testing you can probably do synchronously, right? Where you are willing to wait until that testing has completed before you move forward so that you can make a decision based on that. The challenge is that in a lot of cases, if you look at the current set of security tools that are out there, and if you look at other security testing techniques like manual testing, you don't necessarily have the time to wait for all of these activities to complete. Right? If I want to run a full static analysis scan of my million line of code application, I might not want my Jenkins machine like waiting and waiting and waiting, right? I might need to get a, again, in a perfect world, you would be able to do that because you would be able to say, well, let's do all this different testing and we're going to wait for the end of all this testing. And when all of it's done, we're going to look at the results and we're going to move forward. That's much more of a waterfall type of approach. And if you look at security organizations, they don't necessarily have the power to enforce that, to say, no, you need to go through all of this regression, all these other things from a security standpoint before we move forward. And so a practical reality that we see a lot of organizations having to deal with is some testing can be done synchronously, where you're waiting for the results of that testing before you make a decision about failing or passing the build and moving forward. But in a lot of cases, some of these things have to be done asynchronous. Let's kick this process off. We know it's going to complete after we've given a thumbs up or a thumbs down to this build. We're just going to have the communications and the processes in place to say, hey, that thing that we pushed out? Well, we found some things that are wrong with it. Let's use our totally awesome agile DevOps skills to quickly make fixes and push those out. Again, not ideal, but from a practical standpoint, is something that we see in a lot of cases. So after you've done your synchronous testing, you need to make a decision. From a security standpoint, you need to determine, do I want to pass this build or do I want to fail this build? Very similar to if you're running JUnit, if you're running, for unit tests, if you're running Selenium for functional tests, right? From a security standpoint, you want to make a decision to say, is this build acceptable to move to the next stage in the pipeline, or do we need to pull the cord and stop things? And again here, in an ideal world, you'd love to say, well, our policy for this application is going to be that we're not going to allow any critical or high vulnerabilities. We're going to fail the build if there are any critical or high vulnerabilities that have been identified. From a practical standpoint, how many people think that that would be like a real winning strategy in your organization? The challenge that we see in a lot of organizations, especially folks that have a lot of legacy code where they're trying to, instead of building new apps in pure DevOps environments where they're trying to take legacy applications and start to get those practices to take advantage of more DevOps type stuff, what you see is that you may have a scan and you may have an application that has some number, 100 criticals or highs that are in that application, and it's simply politically not possible for you to say, well, we're not going to pass any builds for the next 2 weeks until this is finished, right? That's potentially a losing proposition. So you may want to make decisions to say, at the very least, I don't want to, politically, I can get the dev team to agree not to introduce new critical and high vulnerabilities, right? And so you've got to determine, like, what is our policy for passing a build? In a perfect world, you'd say, no vulnerabilities or no criticals and highs. From a pragmatic standpoint, that may not be something that's politically reasonable to do in your organization, and you may be able just to say, like, well, hey, we can't introduce any new SQL injections or cross-site scriptings, whatever that might be. And then after you've made a decision on the build, you need to report on that. Either it's back to your Jenkins server or potentially taking the results of the testing and pushing that out into the developer's workflow or change tracking tools to say, we're going to take all the results that came back from this testing, we're going to bundle all the like vulnerabilities up together, and we're going to create defects in Jira. And that's the way that the dev team is going to know that we found new things as a result of this testing. So that's really, when I look at security, application security in a DevOps pipeline, that's kind of the point of view that I have on the kind of stages you go through and the trade-offs that you have to make between what you would like to see in an ideal world or an end state that you would like to get to, as compared with what you're politically able to push through and get all the different stakeholders to agree on. Any questions about any of that so far? Excellent. So as I talked about, many security tools run too long to include in a lot of pipeline builds. If you're going to run full static analysis of an application, if you've got a big application you want to run dynamic analysis, those are potentially long-running processes, and that may not be acceptable to say, well, hey, we used to be able to approve a build in X amount of time, in 45 minutes or an hour and a half or 3 hours. We used to be able to do enough of a build. Now it takes 12 hours because we also included this other step that we're trying to go through. But also, I think it's important to understand that automation, from a security standpoint, automation can't solve all of your problems. And so you're going to need to incorporate manual testing activities into your verification program. And those can be challenging, especially from a DevOps standpoint, if you're trying to build X amount of, get through, X amount of builds per day or something like that, unless you have just a weird, meat cloud of testers waiting around to, jump on new stuff. Again, that's the type of, process that's probably going to happen asynchronously. But it may be one that you want to influence or kick off, based on these, build activities being kicked off. And so, if you look at tracking attack surface over time, that lets us potentially focus our activities on the things that are most important. And so if I've got an application, and since I've done my last build, we've introduced 5 new URLs and 10 new parameters. If I'm doing automated testing, but I don't have a long time to do that, for that testing cycle, I may want to say I only want to do dynamic testing on those endpoints that are new in this application, because I know those have not yet been subject to some sort of inspection. And that may get you and your tool runtime down to a level where it's acceptable to include in the build. Is that going to catch scenarios where the underlying code behind existing pieces of the attack surface have changed and may have introduced vulnerabilities? No. In that case, if you're not testing that stuff, you're not gonna check it. But hopefully we can all agree that at least some testing, or making sure that attack surface has been subject to some testing, is preferable to not having any insight into the security state of that new attack surface at all. Similarly, if you're looking at manual testing over time, or if you have a limited set of resources for doing manual testing, if you want to do incremental manual testing, knowing how the attack surface has changed between 2 weeks ago when we did our last manual test and now when we've got some additional time to do testing, if I know about new attack surface, I can focus my efforts on the new attack surface because I know that that has not yet been subject to that type of testing. And so by understanding more about the attack surface of an application and watching how that changes over time, that lets you be much more pragmatic and intelligent about the way that you allocate your scarce resources. And that's really, in the security world, I think that's that's the hard problem, is making those economic decisions of how do you allocate scarce resources, because nobody has as much, nobody has as many people on their team as they want, nobody has as much time to do the testing as they want. That's just a fact of life, is that you're going to be dealing with resource constraints. And by using this attack surface information, that can help you make better decisions about where to allocate those resources. So the underlying technology that does this attack surface calculation is called the hybrid analysis mapping, or HAM, as it's affectionately referred to around our office. And the original goal of building this technology was to be able to correlate the results of static application security testing and dynamic application security testing. It's been funded via the U.S. Department of Homeland Security, under some research and development contracts. And what we found once we had built that merging engine is that we could also use the underlying data structures to do this type of, essentially we had built the attack surface calculation engine as a side effect of what we needed to do in order to do the correlation. And so what we've been doing recently is looking for other things that we can do with that underlying technology and that attack surface calculation. Just for the sake of whatever, I guess I probably should mention this. The DHS folks funded this research, but don't take that as an endorsement of anything that I say here today. I'm simply up here talking with my opinions about what we've done. As a caveat, no, I don't want to get a call from our program manager saying, "You said what?" But so we're currently, again, phase 2 of a DHS S&T CSD SBIR, which is the gotta have the acronyms. And I was corrected the first time I got a call from our program manager. It was to correct some acronyms that I had left out of some statements that I had made. But again, it's the U.S. Department of Homeland Security, the Directorate of Science and Technology, the Cyber Security Division, and the program is called the SBIR, or Small Business Innovation Research Program. And just as a side note, this is the first time that I've been involved in these types of federal government R&D contracting. So it's been interesting for me, being someone who's spent most of my time working with private sector organizations, working with the public sector folks. But it's been a really interesting program, and it's a great way. The SBIR program, what the different federal agencies, what they do is they determine, here are the technologies that we think would be interesting for us to accomplish our mission. And they put out basically a request for proposal that says, do you think you can meet these needs? And then they walk folks like Denim Group through a kind of progressive stages of demonstrating, prototyping, and things like that. So it's been really cool to be involved in this program, and that's allowed us to develop some technology that we probably would not have developed otherwise. And we've open sourced most of that technology. All the stuff that I'm talking about here today, you can do based on the stuff that's in GitHub and whatnot. And so that's been a cool way for us to develop this technology, to use that for commercial benefit, but also, we made the decision to open source a bunch of it. So whatever. So again, the initial goal was to correlate and merge results from static and dynamic security tests. And after we figured out how to do that, we made it do other stuff, which is more of what I'm talking about today. And like the specific need that we were trying to meet, we saw a lot of organizations that we worked with where they had deployed AppScan, typically Watchfire as their dynamic testing engine and Fortify as their static testing engine. And again, as the industry has evolved and matured, IBM bought Watchfire, HP bought Fortify, now Micro Focus bought HPE software. So organizations had these tools deployed, and the vendors that own them didn't necessarily have a strong incentive to do a bunch of stuff together. And so the challenge we saw was a lot of folks had all this data that they had been producing with their programs, and they needed a way to combine that and make sense of that. Is everybody here familiar with dynamic application security testing? You kind of act like Google. You're going to spider the application to, in this case, you're trying to discover the attack surface of the application. You start at page 1, look at the HTML and the JavaScript, look for all the links, go to page 2, go to page 3, so on and so forth. And so The dynamic scanning engines, they have to go out and spider to identify, to get, essentially guess or to discover the application's attack surface. Again, with some authentication and session detection stuff, you've got to teach the scanner how to log in so that you can have a valid session cookie and whatnot. And once the scanner has identified that attack surface, it essentially goes through directed fuzzing to say, let's see if we can find vulnerable request and response patterns. I'm going to send in SQL control characters. If I get a JDBC error message back, that tells me there's probably a SQL injection vulnerability here. And that typically produces results, or for our purposes, produces results. It's basically the vulnerability type, the relative URL in the application, and that entry point. What parameter, for certain classes of vulnerabilities like a SQL injection or cross-site scripting, what parameter was passed into the application that resulted in this response coming back. Looking at static application security testing, again, you're going to take the source or the binary, do some analysis on that to create a model, and then perform additional analysis in order to identify potential weaknesses and vulnerabilities. And so you're going to do things like data flow analysis. Here where we see we've got this request.get parameter call, that's going to return a tainted input. That gets assigned to the username variable, which is also then considered tainted. The username variable, along with some static text, gets appended together and assigned to the SQL variable, and then that tainted SQL variable gets passed into the sensitive function, which is execute. Again, they're kind of a classic example of a data flow analysis to find a SQL injection vulnerability. So what we wanted to do with hybrid analysis mapping is to figure out how do we take these results from different types of testing and identify where there are overlap situations. So first thing we need to do is standardize on vulnerability types. We settled on the MITRE Common Weakness Enumeration, or CWE. As I like to tell the folks at MITRE who maintain the CWE is the worst vulnerability taxonomy available, except for all the other ones. Right? It is the democracy of vulnerability taxonomies, and it actually works really well for our purposes. And a lot of the tool vendors have mappings back to CWE. And so this is a case where I think we could say standards, or the attempt to create standards, has been very successful, or at least it's helped us a lot along our way. Then we need to match the static and dynamic locations. How do we know if I have a code in a given file? How do I know where that code is going to get attached to the application attack surface? So I want to send an HTTP request to a URL. How do I pick that URL so that that means a certain piece of code is going to run? And similarly, if I'm passing in a parameter, how do I know where that parameter that I send in my dynamic web request, how do I know, or how do I find where that enters the application source code to execute? And so in certain environments, in certain languages and frameworks, if you think of like a raw PHP environment, like that's fairly easy to do that correlation, right? The file structure matches the URL structure. Great, that's fairly easy. In other environments, like if you think about like a Java Spring environment or struts or ASP.NET Web Forms, there's a translation that occurs according to different conventions of like, hey, if you send a request to this URL on the application, this is the code that's actually going to run, and the file name where that's located is totally not associated with the naming in the URL. Similar thing with the parameter parsing. If I pass in this parameter, where does this actually get picked up in the application? And so what we do is we consume the source code and detect the language and framework, and we build this endpoint database. So what we essentially do, we've built the engine, detects the language and the framework, and then builds mappings where it says, here are all the URLs that the application will respond to and all the parameters that can be passed in. And here is the source code entry point that is responsible for that behavior in the system. So to merge static and dynamic results, you basically say, well, I've got a dynamic result. I've got a reflected cross-site scripting at the URL login.jsp for the username parameter. I can query that database, and it says, well, this is a Java Spring application. This is at com.whatever.whatever.logincontroller.java line 62. Then if I go and look at my static results, and I have a reflected cross-site scripting vulnerability that enters that application in logincontroller.java line 62, I can say, I believe this is a match. I believe I have two pieces of evidence about one vulnerability, one static piece, one dynamic piece, as opposed to treating that as two different vulnerabilities. Magic. And so what we found was we could do some other interesting things with that. Again, we built this to solve a specific problem, but in our discussion around the table, I talked to one of the engineers that was working on it. I said, well, it sounds like, could we just do a different query on this data. Could I, for example, do a select star equivalent on that data set, and that would give me all the URLs and all the associated parameters that the application will respond to, regardless of whether or not there are vulnerabilities associated with those points in the attack surface. And the engineer looked at it and said, yeah, we can certainly do that. We can also do some interesting things where if you've done dynamic testing, but you haven't done static analysis, you can still query that data structure and get the entry point in the source code. And so that's something like in an IDE, for example, that we could map, where we would say, hey, I've only done dynamic testing. Give me the URL and the parameter, and I'll show you where to start looking in the source code if you want to fix this vulnerability. It's not as good as having, a lot of the static analysis tools have really good IDE plugins, and you can go and click through the full data flow and watch it steps through the whole data or control flow. So it's not as good as that, but it's better than saying, well, hey, here's the request and response. Developer, go figure out where this hits your, go figure out where this actually hits your application. And so there's some interesting things that we found that we could do with this. And kind of the first example that we'll look at is scanner seeding. Again, one of the challenges with dynamic testing is you don't necessarily, you start out not knowing anything about the application attack surface. You say, well, here's the first page in the application, and again, maybe you've trained the scanner to log in so that you can see both, pages that require authentication as well as pages that don't require authentication. Well, with this data structure that we've built, we've got, in theory, a list of all the URLs that the application will respond to and all the parameters that can change the behavior of the application. And so I can take that and feed that to the dynamic scanner, and that lets me then know about the application attack surface, before we even begin that process. And we'll talk more about this, and I'll demo this in just a second. Just kind of some final thoughts on working with the DHS SBIR program. Again, I think it's something that's been very interesting for us. It's allowed us to develop some neat technologies. And if folks have questions about that, I'm certainly not an expert on it, but again, we've been in the program for two and a half years. If anybody has questions about that, I'm happy as a side thing to answer any of that. All the plugins that we're talking about, again, you can download from the links that I provided, or also if you go and build the ThreadFix Community Edition from GitHub, you can, we've got a download link that you can just pull those tools down. And here's some instructions, again, for later on if you want to install the Zap plugin to look at the stuff that we're doing. And so from this attack surface enumeration, what we're going to find is all of the URLs, all the parameters that are going to change the application behavior, and we're enhancing the system right now to add, searching for cookies, HTTP headers, other points of attack surface. So why is this a problem? It's a problem because a lot of times you've got a dynamic testing engine that has to guess at the application attack surface. There may be things like hidden landing pages that link back into the application as a whole, but where you would never, if you started at the home page, you would never link out to that part of the application. You can also have multi-step processes where the scanner, for whatever reason, doesn't manage to get its way through the workflow. You may also have unknown parameters or debug parameters. I worked on an application, a Cold Fusion application a while back, and for any page in the application, if you would pass in a parameter named D, it would delete the order that had the ID of whatever the value of that parameter was. Why not? And so again, I don't think this was something malicious. I think this was a little tool that, like a handy tool that the developer included, that somehow got cut and pasted into every page in the every part of the application. But those are the types of things that you find. That again, unless you're the developer that wrote it and was thinking about it, if you have code handed over to you, those are the types of things that you probably won't know anything about, and that a scanner is never going to find that because it's never going to see a reference to that parameter named D in any of the HTML or the JavaScript or the traffic you get from exercising the application. This is also really useful if you have mobile applications that are being backed by REST services and things like that. Because you can enumerate those, and then at least, from a dynamic standpoint, what we would typically do to identify REST endpoints is we would, take the mobile application, feed it through like a burp or a zap, out to the REST services. Then we can watch the traffic that goes through. That's going to show us, some subset, maybe all of the REST APIs. But if you have the ground truth of here's all the APIs that are actually exposed, that gives you additional information where you may find situations where there's functionality exposed out in these REST APIs that again, you would not have discovered because it's not intended to be there, somebody forgot about it, or whatever else that might be. And so the benefits of using this attack surface data as a starting point for either automated scanning or pen testing is that you're going to reduce false negatives from scanners because you're going to get better coverage of the application for your standard fuzzing. And similarly, for manual pen testers, this gives them a lot of information that they can use to go in, ask questions, and understand more about the application. And again, identify situations where there may be things exposed that you wouldn't find through your standard dynamic enumeration methods. So we've got a command line client that basically you point it at source code, it calculates this attack surface, and then just dumps it out to the command line. So we've got some instructions on that here, and we can show you what that looks like in just a couple minutes. I have to do post-talk stuff. I shudder to think what else is going to pop up while we're doing these demos. There we go. All right. There we go. A little bit bigger. Okay, this resolution's really doing me a lot of demo favors here. Okay, so you basically run this and point it at, point at a source code base, and ThreadFix detects that. It detects the language in the framework and dumps stuff out. And so what we see here, looking at this, ASP web forms application, we have the very cleverly named a hidden directory and hidden launch page, right? That you would not find, during a normal crawl because there's no links out to that. But by having access to that information, again, we know, hey, this is something we need to navigate to. If we're doing dynamic testing, we want to, hit that page. It doesn't look like there's any parameters, so maybe there's not a lot there to fuzz. But from a manual pen testing standpoint, I've got a question of what exactly is that page there doing about? And as you saw, that ran pretty fast. Just to give you an idea of, to compare this attack surface calculation to a standard static analysis. Let's run this. It complains about the Git directory. There we go. And so that was just running. We just ran the attack surface calculation against the ThreadFix code base, which is 100 and some odd thousand lines of code. And so what we're doing is like a tokenized parsing. We're not doing full data flow analysis, control flow analysis, or anything like that. So it's much faster. The obvious downside of that is because we're not doing full data flow or control flow analysis, we're not finding those types of the vulnerabilities that you would identify from that. But again, from a speed standpoint, the technology is able to chew through this stuff pretty quickly. There we go. So what we've also done is we've built plugins for Zap and Burp and also AppScan that I think may or may not, but it should be available soon if it's not already released. But so we can go in and let's say that we're looking at this budget store. With the plugin, we can go and say tools, import from source. I'm going to import the source code for Budget. I'm going to point it at the running version of the application. Okay. And we can clearly see from the voluminous screen real estate I have here. So just to show here, what you can see is, so we identified by preceding the scan, we found this admin.jsp page that you would not have found otherwise if you hadn't been logged in as an administrator, right? And again, if you look at the application, what you find is that that particular page you can get to without being authenticated, which you probably shouldn't be able to do. What you also find is that a number of these pages will accept this parameter named debug. What does that do? I don't know. But as a manual pen tester, that's certainly really interesting to me. And it's also probably something I'd like to fuzz, just in case it touches a SQL database or something like that. All right. And so by preceding this scan with the knowledge that we have of the application's attack surface, that lets us get a much more thorough coverage when testing the application. And it gives us, if we're doing manual penetration testing, it gives us the ability to, or it gives us additional insight into things that may be interesting that we want to look at. So, there we go. What we can also do is start to use visualization to look at these things. So we can start to look at what, for a given application, we can start to look at what are the different pages that are exposed, what are the different parameters that exposed, for a simple application like Budget or for a much larger application like ThreadFix, where again, here we're enumerating all of the different attack surface. And we can also start to look at how this attack surface changes over time. So I can take version 1 of the application, calculate the attack surface, then wait a while, go to version 2 of the application, calculate that attack surface, and we can see how that evolves over time. And that lets us start to do some additional interesting stuff. There we go. Because what we can do if we have attack surface that we've looked at multiple points over time, we can run diffs of that and start to understand, hey, between this commit in the application and this next commit in the application, here's how that attack surface has changed. And so from a fuzz testing or an automation testing standpoint, if you're looking at, well, we did, the last time that we did a test was here. We just checked in a bunch more code. Here's what our head commit is here. Let's do a diff between the last time this Jenkins job ran and the current time where the state of the Git repository is, and that'll let us identify here are the new pages that have been exposed or new parameters that have been exposed as well. And again, that may let me, what I can do is I can feed that data to something like Zap and tell Zap, I only want you to do automated testing against this part of the application because that's going to get our runtime down to something that is potentially much more manageable. Similarly, if you're looking at tracking manual testing over time, you can understand the last time that we did manual testing of this application was at this point in the code's evolution. Now we're at this commit. Show me all the new stuff that has shown up, or show me things that have gone away since the last time we did this testing. And based on that, let's focus our manual testing efforts on the parts of the application that haven't been subject to that type of inspection yet. Again, the concern here is I have a limited runtime that I'm allowed to, where I can insert myself into that build process. So I have to keep my tool runtimes down to this much if I want to have these synchronous testing tasks where I can weigh in on passing or failing a build. Or similarly, we've got a manual testing program, but we, for whatever reason in this current job market, we don't have all the testers that we want. We've got a couple job recs open because we don't have enough capacity to do this testing. Let me make sure I'm focusing those testers on where they are most likely to find new and serious vulnerabilities that have been introduced to the system. What we can also do is start to pull together metrics. One moment. Where we can start to look and make decisions where we say, let's look at where we were before in the size of the attack surface and where we are now. And we can set up a policy that says, once the attack surface has changed by 5% or 10%, or once the attack surface has grown by 20 URLs or 15 parameters or whatever that might be, you can start to put thresholds in there to say, at this point, we believe the application has changed enough from the last time that we did a full static analysis, or the last time we did a full dynamic analysis, or the last time we had a thorough manual test. You can start to use those to set thresholds to trigger events where you would initiate those longer running activities so that you can essentially true up. Again, because as you go over time, the level or the quality of your security insight is going to change if you've only been doing scanning of stuff when it showed up, when it was new parts of the attack surface, you need to dead reckon where you're at by essentially going back and saying, let's redo these activities. And again, by being able to calculate the, again, either on a percentage or on a raw URL or parameter basis, this lets you then negotiate and look at your budget of here are the resources that we have. Let's determine what thresholds we want to set so that we can balance between the available resources that we have, and we can spread those across the portfolio of applications that we're trying to secure. Okay, so and I've talked about a lot of this stuff, but again, this lets you target your DAS testing to limit your run times. It lets you potentially set thresholds for when you need to do manual assessments, penetration testing. And also one of the things we're playing around with is basically gluing this into Slack and HipChat so that when developers make commits that introduce new attack surface, that's something the team is made aware of. What we want to do is provide that situational awareness to the team so that they understand how the application is evolving over time. As new URLs show up, as URLs may be retired or renamed, that provides some insight to the development team so they can watch that as it evolves over time. And I think I didn't see it. We've got there's another GitHub repository that has all the code that we use to generate those models and whatnot. I'll include those. I didn't see it, or I don't remember seeing it, so if it's not there, I'll make sure that it's in there. But this is something that we're kind of actively working on with a number of different organizations. And so right now we're expanding the model of the application attack surface. Right now we look at parameters and HTTP verbs. In the future we're going to be working on HTTP headers. And we also are introducing the concept of authentication requirement as well as authorization requirements for different URLs. So essentially with that model, you'll have a lens to be able to say, okay, well, I've got 100 cross-site scripting vulnerabilities. Show me which of those can be accessed by an unauthenticated user and which ones can only be accessed by an unauthenticated or an authenticated user. Again, to allow folks to take this data they're getting out of their testing programs and to focus in more on things that matter. I'm probably concerned more about unauthenticated SQL injections than I am about authenticated SQL injections. Also, better visualization. I'm not a visualization guy, but I learned enough D3JS to craft together some visualizations. So that's something I think where, again, that's to provide that situational awareness both to development teams as well as to testers, so that they can see the evolution over time as as applications get new URLs, get new parameters, as things go away. That's helpful for folks as they're trying to, again, understand a little bit more about their application, but also for people that are doing testing to be able to understand more about the application so that they can focus their time and resources accordingly. Yeah, so the question is about false positives. How do we deal with false positives? Like, the challenge is that we're on, if you think of like sophisticated analysis, by that I mean like full data flow, cross-method control flow analysis, like we're on the receiving end of just like whatever the tool, be it Fortify or Checkmarx or Veracode or whatever, like we're just at the receiving end of that. And so what we have seen folks use just from a data management standpoint is to look and potentially prioritize vulnerabilities that have been correlated first to say, hey, we believe this is a, we have two pieces of evidence, both the dynamic scanner and the static scanner found this, therefore I believe this is less likely to be a false positive, and more serious that we need to respond to, whereas the other stuff we have less confidence in that. That's one way I've seen organizations use the data. Also, another thing I'll say about getting the testing integrated into the CI/CD pipeline, sending false positives to developers is a very bad thing, right? Because you have so much credibility, you have X amount of credibility, and every time you send a false positive over, you chip away at that or hack away at that, depending on the organization. And so one of the things that we've seen, if you want to start integrating security testing into the DevOps pipeline, you've got to tune the tool so that you're focused on, so that the tools with the rule sets they're using and the configuration are identifying the high likelihood, high impact vulnerabilities. And there's also typically, I see it as like an onboarding process of, let's run the initial scans with whatever tools we're using with the application, cull out all of the false positives. That gives us a clean set of data to start with. And the hope is that that gives you more confidence in the incremental runs if you're going to be like auto creating bugs and things based on those. You've at least got a clean data set that you're starting from. Cool. All right, well, thank you very much, and I'll be around if anybody has questions. So
This is a gift for LASCON.
So thank you, Dan, very much.
Thank you.